AP Calculus AB. I want to talk about the natural log functions and their derivatives and show you how these properties of natural logs can be applied to make this math much, much easier. So I'm going to start with something really, really easy here. So I'm going to start with this problem. I'm going to find the derivative here. So find g prime at x, given that g of x is equal to ln of x squared. So this is an argument we've been having, and I want to be very clear about this. The question that we're talking about a lot in class lately is, where does this 2 go? And I want to assure you that this is ln of x squared, and this is not equal to ln of x squared. All right? So have to be really careful. If they meant the square of ln of x, they would have to show you this in a different way. And that is to say, they'd have to quantify it this way. All right? So here we go. Let's work with this a little bit now. There are these properties of logarithms. I want to remind you of them. And the first one I want to remind you of is this, that if we have ln of a to the n power, we can rewrite that. What we're allowed to do is this. We're allowed to take this n value here and roll it back and turn it into a coefficient. And it's really, really helpful, because what it will do for us is this. It will give us n ln of a. So look what's going to happen if we do that here. I'm not differentiating right now. I'm just rearranging this to give myself a better look. So I'm going to say, you know what? So g of x really is 2 ln of x. Now this becomes a constant multiple, right? We know how to differentiate ln of x. Oops. Yeah, ln of x, right? And the way we differentiate ln of x is that d dx of ln of x is equal to 1 over x. So that's all I'm going to do here. I'm just going to differentiate this. I'm going to say, you know what? So g prime at x is equal to 2 times 1 over x is equal to 2 over x. And there's our derivative function right here. So here's another example. This one is it's kind of a similar question, I think, and let's take a quick look at this one. This one is, so the next example is this one. Let's try this. I'm going to use g of x because I keep saying find g prime at x, so that's all right. I'm going to take ln of 2x squared plus 1, right? So I'm going to go ahead and differentiate this. Now, remember this, that d dx of ln of f of x, right, and you're really going to get to know this really, really well, is equal to 1 over f of x times f prime at x. And this pattern is something you're going to see a ton in integration, so you might want to just go ahead and start remembering that. So what I'm going to do is that I'm going to start to differentiate this. And as I differentiate this, I'm going to get ln, so I'm going to get 1 over 2x squared plus 1, right, times the derivative of the inside. And the derivative of the inside is 4x, isn't it? So our derivative, g prime at x, our final solution, g prime at x, is 4x over 2x squared plus 1. And I want to start reminding you, look at this for a second. If you believe this is f of x, what's its derivative? Well, the derivative of this would be 2 times 2 is 4. Decremented would be 4x, wouldn't it? The derivative of this is 0. So hopefully you're starting to see this, because if you can start to see this now, you're going to be money in the bank. That there's our f prime at x. And here's our f of x here at the bottom. And if you can see this pattern, I'm telling you, it's going to get good for you. So I hope that that's something that's sticking with you. You want to do one more? Sure. So we're going to do one more. And this one looks like this, I think. This one is, let y equal ln of x times square root of x plus 1. So this is what I want to do. I want to use these rules of exponents again. And the rule of exponents I want to use now is ln of AB is equal to ln of A plus ln of B. So see how by using these rules of logarithm you can really make this a lot easier to deal with, because now what we can say is this. We can say, well, y is really the same as ln of x, and we know what the derivative of that is, plus ln of, and what I'm going to do here, we're here anyway, I'm going to switch this out. This radical, right, this square root is the same as 1/2, a power of 1/2, isn't it? So I'll take my x squared plus 1 here and say that the equivalent of a square root is a rational exponent of 1/2, isn't it? Now look, the other rule of exponents that we've talked about is that ln of a to the nth power is the same as n ln of a. So what am I doing here? What we're finding out is that we're allowed to take this exponential value and roll it back here as a coefficient. So that's how this got here. So I'm going to do that here, and I'm going to take this here, and I'm going to roll it out to here, right? And if you don't mind, I'm actually going to just save time for you. I'm just going to go ahead and do that, and there's that 1/2, right? It was a 1/2 exponent here. I rolled it and put it here. Now we can start to use the rules we know of differentiation of ln functions. Well, we know that the first derivative of ln of x is just 1 over x, isn't it? Plus 1/2, right? Times, to take the derivative of this, we get 1 over x squared, right? That's the rule there, right? It's 1 over f of x, and this is our f of x value, times the derivative of the inside, and the first derivative of x squared plus 1 is just 2x, isn't it? So I think that's going to make sense, isn't it? So hopefully, let's see what we have to do to put this crap together. And this is what I hate. Look, I'm going to cancel this 2 and this 1, right? These are factors, this times this times this, so I can cross that out. I'm going to take this x times 1 is x. Hopefully that's okay with you. Put that here, right? So I'm going to get this now, I think. Isn't that right? So all I'm going to do is this. This is what sucks, and let me just be plain about this. If you're getting ready to take the AP Calc exam, then you need to know this next part. If you're in college calc, you don't, because this is where it gets a little bit whatever. Unless you have one of those professors, it's just a pain in the whatever. So we have to add these two fractions. So what I'm going to do is I'm going to multiply this one by x over x, right? I'm going to multiply this one over here by x squared plus 1 over x squared plus 1, and we'll get x squared plus 1 plus x squared, won't we? All over x times x squared plus 1. And to stop for a second, I wrote this question wrong the first time I did it. So this is the wrong question, but I answered it correctly. So the answer is going to be 2x squared plus 1 all over x times x squared plus 1. There is no factor here that we can take out. I was looking for it too, but there's no factor we can take out. So this is the answer I'm sticking with. So this is my dy dx, if you don't mind. Okay, hope this was really helpful. Just knowing these rules will help you a ton, possibly 2 tons.